Hello all. Continuing on the part where we left off, now we will look at substructure searches in Smart's Cheminformatics. That's my details. I'm Abhishek Nandi. I'm a PhD scholar, and one of my subject area research is bioinformatics AI. So I'm sharing my study knowledge that I am getting from my college itself or from the learnings that I am getting. I'm also chief data scientist at Predict. So let's carry on. So what is a substructure search? A substructure search is a technique used in cheminformatics to find molecules that contains a specific pattern or structure with a larger molecular structure. So we are given a pattern. From there we are trying to find out some information, if that information is there in the molecular pattern or not. So this method is crucial for various applications in chemistry and biology, including drug discovery, material science, and toxicology. Substructure searches enable scientists to identify compounds that possess certain chemical features or functionalities that are of interest for research or development. So how substructure search works? Pattern definition. The first step involves defining the substructure of interest as a query. This query can be expressed in various chemical notation. We are supplying it as SMILES. These are simplified molecular input line entry system that is supplied as an input to the web app that we are building, and from there on we get the output. Or SMARTs as SMILES, ARbitrary Target Specification. Very important terms. SMART is a very important term when we are considering bioinformatics in terms of Python, because it helps us to mingle between the reactant and products using programming capability as well as the logical thinking of the organic chemistry itself. So SMART is particularly powerful for substructure searches because it allows specifying a wide range of chemical patterns, including specific atom types, bond types, and even aromaticity. Database screening. The defined substructure query is then used to screen a database to chemical compounds. The search algorithm looks for matches between the query pattern and substructures with the molecular stored in the database. So matching process. The matching process involves comparing the query pattern to potential target molecules to identify those that contain an exact or partial match to the query. The process can involve both direct pattern matching and more complex algorithms that consider chemical properties and spatial arrangement. So again, after that we get a result retrieval. The output of the substructure search is a list of molecules from the database that contains the queried substructure. So you can see where we are bringing in AI into the picture. You can see the entire thing visually with the help of Python RDKit. So that's our approach. These results can then be further analyzed or used as the basis for additional research steps such as biological testing or synthetic planning. So application of substructure search: drug discovery, toxicology, material science, chemical inventory management. So these are the things that you can do. Probably we'll do it in future also when we carry out the series in a longer way with different kind of things captured in terms of bioinformatics. When my knowledge is more, I will share more, and probably will do big projects and will share my information. So in the coding part, so we have used Python for our interface or the programming language of choice. Our visual web app application, we making it as minimal. We are using Streamlit for creating the web application interface, RDKit for doing all the manipulation in terms of chemistry and the changes. So RDKit.chem and related molecules for chemical informatic functions, including molecule rendering. So again, there is one important part being covered, that is base 64 IO bytes IO for encoding the general molecular images into a format that can be displayed in the web app. So very important part, this one, because we are encoding it in such a pattern so that it can be visible in the web app itself. So draw molecule takes two arguments. One is the SMILE string representing this molecule, and a smart pattern representing the substructure to search for within the molecule. You will see that when we work with the app itself. It first converts smile strings to a molecular object. If the smile string is invalid, it returns an error message. If it then checks if the molecule contains a substructure defined by smart's pattern. If not, it returns a message indicating that the substructure wasn't found. If the substructure is found, it highlights the matching atoms in the molecule and renders the molecule in scalable vector graphics image. So again, we are trying to show the image. It is using the HTML display SVG to base 64. Again, we are using the conversion for it so that we can see the output itself. Then we use the input fields to enter the smart and the smart pattern smiles and the smart pattern for it. When both inputs are provided, it attempts to draw the molecule with specific substructure highlighted. If successful, it displays the image in the app. If there is an error, it displays an appropriate error message. Okay, and again, display logic. If the drawing is successful, the SVG content is converted to base 64 and embedded in an image stack, which is then displayed in the Streamlit app using the st.markdown with the option of unzip allow HTML true to allow HTML content itself. Okay, so here are all the details of the code. You can just clone it or fork it accordingly, and you can get started with it. But before that, I will just show this is the code. So what we did was we brought in Streamlit, we had RDKit, and as we are using that base 64 format, it's being drawn. The first function is to draw a molecule with highlighted structure, substructure, and return SVG as a string. Here we are checking the smile string is valid or not. If there is invalid, we get an invalid response. Check if the substructure is found. Then we use the method to create that SVG format of the file. Then we encode SVG content to HTML display, and finally we are passing in the input patterns. These are the smiles for it. So let's see the thing in action, how it works. So for that, what we need to do is I have named the file as substructure search.py. I use the command streamlit run substructure.py to just use it. Now it will open up here. We'll just wait for a while to come up. It's a web app. Just wait for it. Now it's up and running. So as you can see, like here, it has already given an output because there was some measurement or like smiles was given to it, and it is showing the substructure hydroxide. Okay, OH function is there. So I have kept some of my compounds ready with my self, so that I can give you some options. Like if I give an amino group over here to see if it is there or not in this particular option, that is phenol itself, it will check for it. Say here I have given, now press enter, and it says probably I haven't okay, sorry for this. So substructure not found, as some error handling had to be done. I will just make it working. Now I will use this smile pattern, that is acetoaminophenol. So this example should highlight the amino group in acetaminophen, a common pain reliever. Okay, so I will just use this particular smile option here and pass it along as a smile, and I have the substructure amino group that needs to be found from this. Okay, and I will just hit enter in this. Just let us just check it out, just pass it along. So for this also it was able to find the hydroxylic acid group, but let us find with amino group itself, NH2. Says that it's not there. Let's check for it. Another group itself, hydroxyl group was formed on that. Okay, so let's test this as an aromatic compound, benzene. I have, I'll pass in benzene over here. Again, an aromatic ring. I'm trying to find an aromatic ring over here. I'll press enter. So it finds the aromatic ring. So you see how useful it is to find out the substructure search in the molecule, and it's easier, and I'm trying to find out ways to make it much more easier for everyone to understand. Share the code also for this, so anyone can take an advantage of it and just tweak it around. Here is the code. You will find it in substructure.search, substructure.py. You can, if there are any changes or if you can modify and add some more logic to it, you are free to do that. The main thing to run the app is you need to have Streamlit as well as RDKit installed so that you can get started. I hope this journey of Cheminformatics or bioinformatics and organic chemistry goes on and people start liking it. Show love, join my channel. Thank you.